All right, let's go ahead and read this piece right here to your neighbor, and I will simplify it. Go.
On the open if x prime of x is greater than zero for all x and if f prime is less than zero for all x,
Sorry, I'll go over here.
and
Wrong way.
hold on, now you may lose my train of thought.
Wait till I'm done recording,
Okay.
and then we'll talk about it.
Okay. Yeah, that's why I started answering. Thank you.
Are we done reading? Are we done reading? All right. Here's what it means, and I'm going to go ahead and use a chart. Everybody make a chart. And let's say I have some number, some critical number, and what that number is, we don't know yet since I didn't give you an example. Let's say I have a negative number, a positive number, and a negative number when I test it. Again, there's not an example at the moment. All it means is if I have a negative slope, my original graph is going down. If I have a positive slope, the original graph is going up. And if it's negative, it's got to be going down. The bottom line is going to be using the sine chart. Not the sinusoid sine chart, but the sine, positive, negative chart. Mm-hmm. And that was just a little example of a skeleton model. So let's look at our specific example. On number 3, Castro, let's read.
Find the intervals on which f of x equals x to the power 3 minus 3 over 2 x squared. Is it increasing or decreasing?
So is it increasing or decreasing? And we're going to use that on the sine chart. So let's start by writing out our derivative. What is a derivative of x cubed? 3x squared. Now, when I derive the next one, wouldn't that 2 come down and also cancel out the 2 on the bottom? So we have minus 3x. Now, to find the critical point does not change from what we did previously. So it's kind of like having a review for the quiz right now. We are going to set this equal to 0. So when I do, can I go ahead and take out a GCF? 3x. So I have remaining x minus 1. So on our GCF, not GCF, our factor form, set this one equal to 0 and my second factor equal to 0. We have our critical numbers. The first critical number, when I set that equal to 0, it is still 0. Are we okay with that?
Yes.
Second one is going to give me 1. So here's our sine chart that we were talking about on the front or the top. Let's all make a number line. And let's go ahead and put 2 tick marks, and one at 0 and one at 1. And since our graphs go on forever, I'm going to put infinity and negative infinity. The bottom, we're going to compare it to the f prime. The top one, just the function. So let's start testing out some numbers. Now, what numbers you pick really does not matter. So between 0 to 1, I think it's safe to test out 0.5. And then for after the 1, how about we test 2 or 3? Does it matter? What number do you guys want? 3? How about something less than? -1. Seems pretty clever. All right, so when I'm testing the point, we are going back to this piece right here. Are we here for the test? You can't? You said you were going to come in during advisory. What happened? Okay, so when do you want to do it? Tomorrow when? 8th period? Got it. Thank you. Have a good one. So let's test the points here. So I have these 2 components. They're in parentheses. I have 2 people talking over me. Feels great. When I plug in the -1 into the first one, we get a negative. Into my second factor, we get another negative. So we have a negative times a negative is what? Positive. So let's go ahead and put positive. The next piece, let's go ahead and test. Plugging in 0.5 is some decimal, but it's still some positive decimal. Second one is going to give us what? Negative. So our result is negative. And then let's test our third point. And we know that one is going to be positive on both. So our slope is positive. So then our original function is going to be, if the slope is positive, the graph is going up. If the slope is negative, the graph is going down, and then it is going up. And specifically, if I were to make this into a continuous function, the graph is going to behave in this manner. Now, how high and above? It could be extremely lower than what I already have, but in general, that's what the graph is behaving. So is everyone okay with the sign chart?
Yes.
All right. So then, here's what the AP test wants. It says, is it increasing or decreasing? So let's write out the function is increasing, and we know it's increasing from negative infinity to what number right here? The first one's increasing here, second one is increasing here, so it's jumping, so we need a union. Negative infinity to the 0, union, and 1 to the infinity, because that's where it is positive. And our reasoning would be because f prime is positive. You can't just say it's increasing because the graph is going up. That's not enough. So can I say the same thing for the decreasing, but vice versa? Function is what? Decreasing on, and there's only one location that it's decreasing. From 0 to what? 1. And the reasoning is because f prime is doing what? Is negative. So then I want you guys to go to the previous page, and let's answer those 4 questions on the bottom somewhere. So the previous page. Colin, let's read the first one right here.
The derivative of a function that is increasing will always be.
It'll always be what? Positive. And then Allegria, let's read the second one.
The derivative of a function that is decreasing will always be.
What is it? Negative. All right. And then it says derivative of a constant function. I'm going to go ahead and give you an example. And it is an Algebra 1 example. Constant means there is an x or no x? No x. I'm going to give you a random example. Y equals 2. So if I give you y equals 2, isn't that a flat line? And specifically a horizontal line? What kind of slope does that have? 0. And what was another phrase that I use? It is something tangent. When the slope is equal to 0, it's got a horizontal tangent. Okay, if you can make a horizontal line, which is a constant function, our slope is equal to 0. And then a function that changes from increasing to decreasing or vice versa is called the relative extrema. And that's the one that we're going to look at on the bottom piece. Yep. So I guess I should have waited on the 4th one, but that's okay. All right. So let's go ahead and finish that piece on the bottom here. Normally I would have you read this, but are we okay if we just not read and just answer the question? Classify the relative extrema means. Is there a relative minimum? Or is there also a relative maximum? So I'm going to start labeling on these. Go back to the picture that we kind of made a general graph on. By looking at this, what is this called? Relative max. What is this called right here? Relative min. And we know that is the case because of the following reason. Relative max happens if the slope is going from positive to negative. And then the relative minimum goes when the slope is going from negative to positive. So let's write that out. So classify, so we have the function has a relative max at, what is my x value? 0, because f prime changes from positive to negative. Could I mimic that in a vice versa form for the minimum? So the function has a relative minimum at x equals what number? 1, very good. Because f prime changes from negative to positive this time. And that order does matter whether you're starting with a negative or positive, because that's going to differentiate your maximum and minimum. Is everyone okay with that?